Hello and welcome to a new webinar series covering innovative applications delivered to you by Waters. I'm Godo Bosch and I will be your host. I have been with Waters for over 30 years in various positions. In the last decade, I have been involved in the clinical users' needs and providing with different solutions and especially communications and as well webinars like we have today. Today we are going to present the development of the UPLC-MS analysis for clinical research of free testosterone in one presentation, and then following by the free T3 and free T4 versus free T3. Our presenters are Stephen Balogh and Rob Wardle. Both have started their career at Waters in 2010 at our mass spectrometry global headquarters in Wilmslow in the UK, which is near Manchester. Stephen has been active in developing and validating bioanalytical methods following the CLSI guidelines, focusing strongly on therapeutic drug monitoring. In addition, he has supported newborn screening, vitamin and steroid analysis, including this clinical research method for free testosterone. While Rob has developed and validated methods on vitamins and in particular vitamin D metabolites, as well as estrogen, a large panel of steroid hormones, and more recently, the application he will present today on free T3 and free I'm mixing this up always, free T4 and free T3. He has in parallel developed an in-depth knowledge of online and offline automation. Before we start our session, I will give you some information on how to use the platform. We encourage you to ask as many questions as you want, and these you can submit on the left of your screen. You can see a box in there. I hope you can see it, but there is an arrow now showing it, and that's where we'll look at your questions and we'll answer them during the Q&A session at the end of the webinar. And your opinion as well is very important to us. We'd like to get your feedback, and we have a very short survey on the right. I'm sorry, the slide moved automatically, it seems. Trying to go back. Here we go. Yeah, so on the right you have a short survey that we'd like you to fill that will help us improve what we're delivering to you and understand your future needs. And in the middle, below the main screen, you will see some documents that are there for you to download, which are complementary to the presentations today. So without further ado, I will hand over to Stephen for his presentation on simplified equilibrium dialysis for the UPLC-MS analysis of free testosterone for clinical research.
Yeah, thank you for the introduction, Godo. And hello, everyone. I'd like to welcome you to this talk, where I will be discussing the subject of free testosterone analysis in serum for clinical research. Within this presentation, I will go through why measurement of free testosterone for clinical research may be of interest and why LC-MS-MS is the technique of choice. We will also look at the important role that chromatography plays. I will then go through the water solution for the analysis of free testosterone using LC-MS-MS. This uses a simplified, fast workflow which can be comfortably performed in a typical working day. Finally, I will present the performance characteristics before summarizing. Before I start the presentation, I'd just like to present this poll to you today. So just interested in knowing how you test for free testosterone today, if you do at all. So I will leave this poll up just for a while so you can respond as you see fit. Thank you. That's great. We've got nearly half of the group responding, which I really appreciate. And we can have a look at the outcome. Yeah, it would appear that 30% of the group use equilibrium dialysis with LCMS, with some using ultracentrifugation. Immunoassay is a popular option. The free portion using a formula as well, and then a quarter of the responders do not test for free testosterone at all. So thank you for your input there, and we'll proceed with the rest of the presentation. You might want to consider why you wish to measure free testosterone and why you use LCMS-MS. I won't dwell too much on the clinical side of things, but testosterone is an important androgen steroid hormone that fulfills several roles biologically. It has been widely analysed by mass spectrometry in the past. Indeed, Waters has issued several application notes covering the analysis of testosterone in a clinical research setting. The analysis of free testosterone is more difficult. The great majority of testosterone is unbound to proteins such as albumin and sex hormone binding globulin, SHBG, so typically less than 3% of the total testosterone. As a result, you can see that this creates a challenge for analytical sensitivity. Furthermore, we also targeted a method that would demonstrate precision of no more than 16.5% and a bias of no greater than 13.7%. And with these goals in mind, LC-MS becomes the technique of choice. There are two main techniques that laboratories use to measure free testosterone. The first, briefly, is ultrafiltration, where you place a serum sample in an ultrafiltration device and centrifuge it, and the free portion is passed through a semi-permeable membrane and taken for analysis, and the protein-bound portion is retained on the filter. In equilibrium dialysis, often abbreviated to ED, which we'll talk about today, a serum sample is placed in a matrix chamber and a buffer added to an adjacent buffer chamber on the other side of a semi-permeable membrane. The samples are then mixed under a controlled temperature until equilibrium is achieved. Following this, the free portion in the buffer chamber is processed for analysis, leaving the remaining protein-bound analyte in the matrix chamber. There is, however, a historical perception that even the gold standard equilibrium dialysis techniques might be deemed too technically challenging to implement in laboratories. Additionally, they can be quite time-consuming, and you see some examples in the literature where they describe an overnight step. And this would make such an approach less appealing for a high throughput clinical research setting. Now, we'd like to look at the method we've developed in Waters for the analysis of free testosterone, and we'll start with the sample extraction procedure. We take a relatively small volume of just 200 microliters of serum and 400 microliters modified Hebes buffer in an equilibrium dialysis protocol. The method requires a temperature-controlled chamber mixer, and the mixing step is quite rapid in that it only takes 2 hours to achieve equilibrium. And as you can imagine, that has considerable benefits to the workflow. I should point out at this stage that it is important that you perform the incubation at 37 degrees Celsius, because even small deviations from this temperature can give rise to relatively large differences in the determined concentrations. At the end of the ED procedure, internal standard is added to the dialysate and MTBE used in a liquid-liquid extraction step, with the top layer dried fully using nitrogen heat, and then finally reconstituted for injection. The final sample is stable in an autosampler for 24 hours at 10 degrees Celsius, and there is sufficient volume for reanalysis if required. Now let's consider an overview of the system used for this method. An Acuity I-class fixed loop, that is FL, system is used to perform chromatographic separation on an Acuity BAH C18 column, the dimensions of 2.1 by 100 millimeters, and a particle size of 1.7 micrometers. The analytically sensitive Xevo-TQ absolute mass spectrometer is used in this application, and it's controlled by MassLynx. TargetLynx was used for the data presented in this part of the presentation, though Waters Connect with Quant Review software may also be used, as you will see in the presentation following this. Moving on to the UPLC details of the method. An injection volume of 25 microliters of the sample is made onto the column at a temperature of 50 degrees Celsius, and the mobile phases are water and methanol with the addition of a small amount of ammonium fluoride. The purpose of the addition of this ammonium fluoride aids with analytical sensitivity in view of the goals set for this clinical research method. Chromatographic separation of free testosterone from everything in the dialysates is over 4.5 minutes, with a gradient separation and column wash and equilibration steps incorporated. It is important that testosterone is eluted in the region of relatively low background noise. And one further consideration is the grade of the solvents used in the mobile phases. Some solvents we evaluated gave rise to large amounts of noise or reduced peak height, or sometimes even both, so thus negatively impacting the analytical sensitivity achievable. All in all, the runtime was around 5.3 minutes injection to injection. Therefore, you can analyze 11 samples in an hour. Now, if you consider the conditions used for the Xevo-TQ absolute mass spectrometer, detection is performed using the protonated adducts in electrospray ionization in positive mode. The instrument is set to unit resolution. That is approximately 0.7 Daltons at full width half maximum height. The cone voltages and collision energies used are presented here, with the chosen precursor and product ions, and qualified product ions are presented in parentheses. For this method, we used relatively high source and desolvation temperatures, respectively of 150 and 650 degrees Celsius. Once again, this was in view of achieving our analytical sensitivity goals. This slide presents quantifier and qualifier MRMs of testosterone in addition to the quantifier MRM for the internal standard. The choice of mobile phases, column and gradient allows testosterone, as previously mentioned, to elute in a region of relatively low background noise, with a focus again on analytical sensitivity. The 13C3 labeled testosterone internal standard used ensures a perfect retention time match, which in turn promotes good linearity and minimizes matrix effects. Staying on the subject of linearity, the CLSI linearity experiment, in which low and high sample pools are mixed in known ratios, demonstrated linearity of this clinical research method for free testosterone over a range of 0.5 to 650 picograms per milliliter. Routine analysis, where we used calibration lines constructed over 1 to 500 picograms per milliliter, and these were shown to be linear on all the occasions we ran them, with a coefficient of determination of at least 0.995, as shown on the example on the slide. I would like to point out that the calibrators were prepared in the modified TPS buffer, then taken through the previously described liquid-liquid extraction protocol. Finally, absence of carryover was demonstrated from the top concentration 500 nanogram per milliliter calibrator into subsequent blank samples. We now come to precision performance. 3 serum pools were prepared in-house using combinations of individual serum samples, pooled unstripped serum, and stripped serum samples. The precision testing was performed by extracting 5 replicates of these low, mid, and high samples on each of 5 occasions. Thus, we had a total of 25 extracted samples at each QC concentration. Statistical analysis of within run and total precision was performed using the Analyze It add-in from Microsoft Excel. As you can see on the bar graphs shown here, these were determined to be no more than 8.4% across the range of 2.79 to 134 picogram per milliliter. You may recall that our goal was 16.5%, so that goal was met. Continuing on the method performance characteristics, we come to analytical sensitivity. This was evaluated by preparing and quantifying a series of testosterone samples in modified Heapy's buffer at increasingly low concentrations. On 5 occasions, 10 replicates of each sample were analysed, making for a total of 50 samples. And from this, the determined lower limit of the measuring interval, the LLMI, was 0.5 picogram per milliliter. This was the concentration at which total precision was less than 20% and bias less than 15%. Though, as previously noted, the calibration range started at a higher concentration of 1 picogram per milliliter. In these overlaid chromatograms, the black trace is a blank sample, and the green trace represents the 0.5 picogram per milliliter LLMI concentration. The magenta trace is the 1 picogram per milliliter lowest concentration calibrator. And finally, the red trace is 5 picogram per milliliter. On each occasion, the blank sample concentrations were determined to be no more than 20, were determined to be less than 20% of that of calibrator 1. Finally, in this method performance section, we come to a discussion on accuracy. Niquas, based in Birmingham here in the United Kingdom, provided 45 male serum samples, and these range in concentration from around 50 to 270 picograms per milliliter. The samples were analysed using this clinical research method over several days, and results compared to the all-laboratory trimmed mean, that's the ALTM, provided by Niquas. Analyze It for Microsoft Excel was used to perform regressions, and with this we saw a passing Bablock equation of y equals 0.947x minus 2.869 and a bland Altman mean bias of around minus 7.6% presented on this slide. And with that, our bias goal of 13.7% or less was met. To summarize, a new UPLC MSMS clinical research method for the analysis of free testosterone from just 200 microliters of serum has been developed. The method allows for sufficient analytical sensitivity to analyze low part per trillion concentrations. Additionally, the precision goals were met in a runtime of a little over 5 minutes, and good agreement with an external quality assurance assessment scheme was shown. And then finally, the fast 2-hour equilibrium dialysis step, along with the method performance demonstrated, goes some way to challenging this perception that equilibrium dialysis should be seen as technically burdensome or too lengthy to incorporate into a routine clinical research workflow. So with that, I'd like to thank you for taking time out of your day to listen to this talk. As previously mentioned, please submit your questions. You can see the associated application notes, which you can find from the waters.com website. Alternatively, you can merely scan the QR code here, and that will take you to the relevant application note. So thank you for listening.
Yeah, before we jump into the next presentation, if you have maybe 1 or 2 questions, we can take it. Well, I see a few popping up. So Stephen, if you're ready for them.
Absolutely.
So what's the first one? So yeah, I think the very first one was saying, well, did you also perform some precision experiments on real samples instead of spiked ones?
The precision experiments were real samples. We got some individual male serum samples because you can understand that spiking a free testosterone sample is quite challenging. Because if you're measuring total testosterone, it's fairly straightforward. You maybe do a solvent spike into a blank matrix, but there was a bit of iteration, so we kind of looked at the samples in our inventory and used ratios to create these samples. One consideration is that you need quite a large sample volume, so 200 microliters times 5 occasions, times 5 replics, times 5 runs, you soon get to 5 or 6 mils. So yeah, that's why the in-house pools were created.
Okay, thank you. Maybe we take a second one and then we'll move to the next presentation. What protocol apparatus do you use for ED? Is there an equilibrium after 2 hours using this protocol? Literature usually states equilibrium achieved after 6 to 24 hours.
Yeah, that's a good question. We use the Thermo RED devices for this, and the R in this case stands for rapid. The standard procedure as it is a 4-hour step mixing at 250 RPM. We found that in our hands we could achieve similar results using a 2-hour mix at 800 RPM. And then furthermore, we then validated that there was no change in concentration after steps of 6 hours and 8 hours. So that and the EQA data suggested that we truly had achieved equilibrium at this step. I would just asterisk that by saying that every mixer will be different. So it's important that this needs to be validated in each lab with different bits of equipment, or even if you have the same equipment but 2 different mixers, you probably want to validate it on both your mixers.
Okay, thank you very much for this. So we'll move to the next presentation, and we'll try to answer all of the questions that came in already for the free testosterone application. So yeah, to our next speaker, Rob, you're on. Are you okay with sound?
So thank you, Godo, for the introduction, and welcome everybody. And thank you for taking time out of your day. Oh, can
you? You're freezing, Rob.
Yeah, thank you for taking time out of the day to join us for these webinar presentations. So, presentation, I will do the thyroid. Okay, I'll switch my camera off. Let's try that. I will go through the thyroid hormone pathway and the benefits of LC-MS/MS to analyze these metabolites through the simplified workflow, and like the free testosterone method, we're able to perform this within a typical working day. And then, of course, finally, I'll show some method performance data before summarizing. So the thyroid is a butterfly-shaped organ that is located in the neck, and it controls the production of thyroxine, which is also called T4, as it has 4 iodine atoms. And then this can also be converted to triiodothyronine, which is also known as T3, by the removal of an iodine atom. And this is done in other organs and tissues. So this is thyroxine and triiodothyronine are produced by a feedback loop. So it starts with the hypothalamus, which releases a hormone called thyrotropin releasing hormone, or TRH. And this then goes on to trigger the pituitary gland to release thyroid stimulating hormone, or TSH. And TSH then stimulates the thyroid to release T4. And when levels of T4 increase, they prevent the release of TRH, and this provides a negative feedback. When T4 and T3 levels reduce, the feedback loop starts again. So the free portion of T4 and T3 are the active portion, and these play many important roles within the body, such as regulating the metabolic rate, heart and digestive functions, muscle control, brain development, and also brain maintenance. And around 99.95% of T4 is actually bound to protein, and approximately 99.7% of T3 is bound, and meaning that the circulating free T4 and free T3 concentration levels are very low within the body. And in addition to this, the free portions, as I've said, are the active forms. And that's because they can move freely into tissues where they are needed. And so because the free portion is the active form, this is the desire, there's a desire to calculate the concentration of these for clinical research methods. Another consideration is that there's a small portion of reverse T3 present in the body. And this is where one of the iodine atoms bound to the structure is in a different location. And this is shown in the images on the left of the slide. And it's thought that reverse T3 is inactive. So we do want to differentiate between that and T3. And analysis of free T4 and T3 is challenging, and this is due to the low analytical concentration levels required. And immunoassay methods are quite prone to interferences. So LCA is an accurate and analytically sensitive method for the analysis of free T4 and free T3, as we are able to obtain the low concentration levels required for the method, and also chromatographically separate the free T3 from reverse free T3 to ensure that it does not interfere. And also, as T4 has a different mass to T3, these can easily be differentiated with the mass spectrometer. The main issue with LCMS methods to analyze these compounds, however, is that often lengthy sample preparation techniques are required, such as using equilibrium dialysis, as Stephen has previously pointed out. And a lot of these methods are typically, a lot of the equilibrium dialysis methods are performed overnight. And so just to show you, to ensure that the inactive reverse T3 does not interfere with free T3 in an LCMS method, we need to chromatographically separate it, as they share the same mass to charge ratio, so the mass spectrometer can't differentiate between the two forms alone. And this chromatogram nicely shows the separation of these two compounds, and in our application that I will come on to. And therefore, we can see that free T3 will not, reverse free T3 will not interfere the free T3 concentration. So now let's take a look at our application note. So to separate out the free portion of T4 and T3 from the bound form, we perform equilibrium dialysis using as Stephen mentioned, the ThermoRed devices. And we perform equilibrium dialysis because it's seen to be the gold standard approach today. And using the RED devices, we were able to create a relatively simple procedure, and where we added only 200 microliters of the device, equilibrium dialysis procedure, and then sample extraction using and the whole process could be performed within a typical working day. But rather than for the ED, rather than faster 2-hour approach to achieve, for this method it was slightly longer to get full equilibrium. So I settled on a 5-hour dialysis. As I said before, following the ED process, we added internal standard to the dialysate, along with a sample diluent, conditioned an Oasis MAX microelution plate, transferred the dialysis directly to the SPE plate, and then washed the sample and diluted into a collection plate, and then simply diluted the eluate prior to injection. So no evaporation was required. For the LCMS analysis, an Acuity UPLC I-class FL system was used to perform chromatographic separation, and this was done on an Acuity Premier HSS-T3 column. Detection was performed on the analytically sensitive Xevo TQ Absolute, and this was controlled using MassLynx. We then processed the data using the newly released Waters Connect with Quant Review software, and I'll show some of the images later. Will show the software in a bit more detail. For the LC, 35 microliters of sample was injected onto the column, and this was at a temperature of 45 degrees Celsius. And mobile phase A consisted of formic acid in LCMS grade water, and mobile phase B was formic acid in LCMS grade methanol and acetonitrile mixed together. The chromatographic separation was performed across 2.5 minutes with the gradient separation, followed by column wash and equilibration prior to the next sample injection. And also, just to note, during the column wash and re-equilibration phases, we did increase the flow rate as well. And this was to speed up this process so that we could minimize the injection to injection time. And overall, this gave us a reasonable runtime of approximately 3.5 minutes injection to injection, allowing for the higher throughput of samples, whilst also importantly maintaining the chromatographic resolution of 3T3 from reverse 3T3. And then if we just take a look at the Xevo TQ Absolute conditions, we performed detection in positive ionization mode using the voltages and temperatures shown in the slide. The instrument we set to unit resolution, which is approximately 0.7 Daltons at full width half maximum. Sorry, I'm just going to move on to Stephen's. I believe I'm breaking up. Bear with me, sorry. Hopefully you can hear me better. Oh. Okay, hopefully this is better. Apologies for that. Even though we're sat right next to each other, it seems my laptop is not working as well. Where was I? Yeah, so the TQ absolute conditions, we ran the unit resolution being approximately 0.7 Daltons at full width, half maximum height. And as you can see in the table, the mass to charge ratios of our analytes are shown here, and also the cone and collision voltages that we used, including the qualifier ions. So chromatographic separation was achieved using the previously described method on an Acuity Premier HSST3 column, and having the injection to injection time of approximately 3.5 minutes. So the chromatograms that you see here, these are an individual serum sample that has gone through the equilibrium dialysis procedure and then extracted and analyzed using our method. And the calculated concentrations that we achieved show a free T4 concentration of around 4.95 picomoles per litre, being quite low, and free T3 concentration of 7.12 picomoles per litre. And this is processed using the Waters Connect QuanReview application. So you can see the nice images displayed here. The method was shown to be linear for both free T4 and free T3 analytes when quantified across the ranges of 1.3 to 129 picomoles per litre for free T4 and 1.55 to 154 picomoles per litre for free T3. And this was done again by mixing a low and high pool sampled together in known ratios to give up to 11 different samples covering the concentration ranges. And in addition to this, calibration lines were linear across all occasions of method testing performed, where we had a coefficient of determinations of greater than 0.995 for all of our batch runs. Precision testing was performed by extracting 5 replicates of a low, mid, and high sample, and this was done by spiking dialysate buffer on each of 5 occasions, giving a total of 25 extracted samples at each QC concentration. So the QC samples were prepared by supplementing T4 and T3 into the dialysate buffer at the concentrations shown in the table. But we also obviously wanted to look at include the equilibrium dialysis procedures. So I also performed precision on a serum QC, where 5 replicates of this were put through the red procedure and then extracted on each of 5 occasions. We then process that data in Waters Connect QuanReview application and then perform statistical analysis using Analyze It in Excel. And within run and total precision were found to be less than or equal to 5% CV for the dialysate QC samples, and then less than or equal to 9.6% CV for the serum QC samples. For analytical sensitivity, we perform this by extracting and analysing 10 replicates of low-level samples across each of 5 occasions. Again, due to the limitations of being able to spike a stripped matrix, we did this instead using spiked dialysate buffer at low levels. And we found that the lower limit of quantification to be 0.97 picomoles per litre for 3T4 and 1.15 picomoles per litre for 3T3. And this is the point where our CVs were less than or 20%, and our signal to noise ratio, having been processed by peak to peak, was greater than 10:1. And also we looked at method comparison. So we compared our method to the CDC host referent measurement procedure for 3T4, and this was done on 40 samples. After analysing those samples, we performed statistical analysis, and a passing Bob-Block analysis demonstrated good agreement with a small non-proportional bias, and we had an equation of y equals 0.9198x plus 1.243, and an Altman-Bland analysis also showed a minimal bias of 0.07% when we value assigned our calibrators. And so finally, just to summarize, an LC-MS clinical research method for the analysis of 3T4 and 3T3 in human serum has been developed. This method had a simplified equilibrium dialysis procedure available from a commercial supplier, which allowed for the equilibrium dialysis, extraction, and analysis of the samples to be performed within a typical working day. We've described the importance of chromatographic separation of the reverse 3T3 from 3T3 to allow for selective quantification. And finally, I've showed that the method to have excellent precision, good agreement to the CDC host phase 1 scheme, and also excellent analytical sensitivity required for a clinical research method. So with that, I'd like to thank you all very much for your attention, and we welcome any questions. Thank you.
Okay, I had lost my control buttons, so I'm back. Sorry for the delay. Well, thank you for the presentation, Rob and Stephen. So we got of course, a few questions specifically related to your presentation, Rob. So we'll take maybe one or two now, and then we'll take all the other ones. Where's the first one? Yeah, well, I mean, there is one here that says, did you say that ED was reached after 7 hours? The Waters application note did not say that. Well, I'm not sure you were that specific.
So the application note, we didn't include the time we performed the equilibrium dialysis for. I did a time course experiment from 2 hours up to it would have been greater than 16 hours overnight, and actually found that it seemed to take longer than what Stephen found with the free testosterone. I found that around 4 hours was the first time point where I got comparable results to the longer times, and so I selected 5 hours. So it was giving it the extra hour to be sure that we'd reach that equilibrium from the test results that were achieved.
Okay, thank you. Well, I have two that are related, so I'll try these. What are the levels of reversed T3?
That's a good question, and I guess I would have to come back to you on that question. It's something, yeah, I'd have to look into more. I would say they are lower than T3, but I'd have to find that out.
Okay. And then the related question, which is again not well, anyway, I'll say it. So how low is the LOD? The baseline looked a bit noisy, and you have seen difficulties with. Have you seen difficulties with the integration of peaks?
Is this for the 3T, 4T3 again?
It is for
relating to this
application.
Yeah. So in terms of the integration, I didn't have to perform any manual reintegration for any of the peaks, the data. It was all automatically processed in the QuantReview software. The background for 3T3 in particular, I think that's probably what it's referring to. The peaks that come out after, I'm not entirely sure what they are at this stage, and we would have to do more analysis to see if we could find out what they are. But they are chromatographically separated away from our 3T3 peak, so they shouldn't impact quantification of that. And the sample you see here is, as I say, it's a real serum extract. For 3T3, we had, oh, sorry, that's the sensitivity one. Let's go back further. That's our LOQ, our determined LOQ. So that's our 1 picomole per liter sample, which is, a really low level. Admittedly, this is spike dialysate. So with a serum sample, we may get slightly more background. That being said, this is a real serum extract through the ED process, and you can see at 7 picomoles per liter, we have a really, really nice peak there. So if you take that 7-fold down, I don't think you will be too dissimilar to what we see here. So hopefully that helps to answer that question.
Okay. Yeah. Thank you. Thank you. Maybe a last one, and then we switch to the free testosterone. How robust is the method as the column degrades? Is there loss of resolution between reverse T3 and T3?
So that's a really good question. In terms of the robustness testing for this method, I would have injected around 2,000 sample injections for during the method testing, and I didn't see really any detrimental effects over that amount. We haven't pushed the column to its limits. It's something that I unfortunately didn't get the chance to do during the method development and validation work. So to kind of see at what point we do start to, lose either the resolution or we start to get chromatography issues. One thing I will say though is that we're performing equilibrium dialysis to get a relatively clean dialysate buffer. Okay, it does have a lot of salts present in there, but then we also perform a ion exchange SPE procedure on that sample dialysate. So we should be getting a very clean sample that we inject onto the LCMS system. So it's not something that I am too concerned about, and I believe that the 2,000 injections is you know, a minimum, really.
Excellent, thank you. So a bit over to the free testosterone. So we had earlier on some questions. How is the correlation between free testosterone versus calculated one done?
In the method presented here,
it was a question that came in very early, so
okay,
yeah.
That's fine on the question.
Unfortunately, I mean, it's not specifically stating, you know, where it came up.
Sorry, I'm not staying which one. Oh, right. The correlation between tested free testosterone and calculated.
Yeah.
I'll explain. I can see there's a lot of questions. The information presented here is a very high-level overview of the work that's in the APS notes, and furthermore, there's extra work that didn't appear in the APS notes. So, for example, here we didn't show the interference testing, and indeed the APS note there's all kinds of equilibrium experiments that don't appear in the final text. But I think the question is the correlation. So that is it's a special bit of software you can buy and use with Excel, and that performs all the regressions for you. So we received a bunch of concentrations. I talked about the ALTM. I probably could have expanded that because the ALTM includes predominantly aminoassays. So if I recall rightly, something like 30 different aminoassay methods for each sample and 5 MS methods. As it turned out, the determination seemed quite close, so that's why the ALTM came quite close overall. Hopefully I answered that question.
I think it gave already a lot of answer. Another one is there any kits, or have you used any kits for the standards?
No, we bought the certified reference material, and everything was measured, spiked in using calibrated equipment, gravimetrically.
And then still related to that application, I mean, do you have any idea of the LOQ?
Yeah, I talked about the LLMI, so that's the concentration at which the precision was no more than 20% and the bias no more than 15%. You can see that the MRM of testosterone is inherently quite noisy, which isn't the case for the internal standard. So yeah, just to start the calibration line at double that concentration made a lot of sense, just to allow us to achieve good calibration on every occasion. And you know that the 5 days or 5 occasions, I saw this question about occasions, equations, it's the same as days, it's just a slightly longer word. Yeah, we demonstrated that running several batches, you could achieve that 0.5 picogram per mil quite precisely with a good accuracy.
Thank you. Maybe a last one, and then we'll move again to the other application. Was there any comparison done with the immunoassays for free T3, for free testosterone? Sorry, jumping ahead.
Yeah, again, that would have been with the Acumis, the NEQUAS samples. So we received a spreadsheet from NEQUAS, and it had the immunoassays. So I chose not to specifically do that regression, but we could easily do that. And as I say, the MS method results we provided with were similar in any case. So yeah, generally the agreement was good.
Okay, cool. Thank you. Back to the 3T3, 3T4. Oh, we got many more. I mean, that came in afterwards. Pick one randomly. What sort of binding assessments did you do for the labware used for your pre-T4 procedure?
Yeah, that's a very good question. So these compounds are very sticky, as I'm sure those that are familiar with them know. A lot of the method development work was found to be quite challenging because of this being one of the reasons, making sure we didn't, minimize the absorption effects. So one of the key parts of this method is actually the sample diluent that we added to the dialysate after the equilibrium dialysis procedure, which minimized the absorption to the surfaces of the labware. So in terms of the extraction itself, it was all plate-based. So we didn't use any glass. It was all performed in either the thermo-red device plate or the Waters 2 mil or 1 mil collection plates. But the sample diluent was added and found to minimize the absorption after the equilibrium dialysis procedure was performed. Yeah, it was a challenge, but that diluent, it contains a high amount of ammonia, which seemed to be the key to stop that from happening. And it also worked well because we performed ion exchange SPE with our max plate, so we need to start by adding a base for that to work.
Thank you.
Just to add to that, I did look at time course experiments as well in different labwares with different conditions to see, over time what happened and if we got a reduction in peak areas of our analytes.
Thank you. And very quickly before we end the session, I mean, how long did your method development take? In fact, the question is for both, but let's take you, Rob. I mean,
this particular application is certainly, well, both have been challenging. So for me, I actually learned. Stephen ran his before I did. Well, we were kind of co-developing, but we learned a lot off each other, which helped us get through maybe a bit quicker. But probably the method development before we even got to that verification work, we're probably 6 months.
Yes,
I would say.
That order.
So yeah, it wasn't quick, but I think we both got to a good place, and the results that we got at the end hopefully show that as well.
Thank you. Thanks for all the answers. We could not answer all the questions, so we'll do that offline. And these presentations will be, I mean, it's being recorded, so you'll be able to watch them as well afterwards. Thanks for joining us for this hour, and we'll have more events to come. So watch your mailbox and the social space. Thank you again, and have a good rest of your day. Bye-bye.